start. So I hope there are a few people who are attending from the last session, and there are a few people who are attending due to this concept and scratch. So whoever are attending newly, welcome to DURGASOFT, where we are going to train you on the Docker and Kubernetes. So hi, I'm Chaitanya. I'm an DevSecOps engineer. Okay. So that is my designation. Currently, I'm working in Docker, where I'm working as a level 5 consultant in the research and development. So that's about myself. So when we go into the concepts, so in the previous session we just went through what is meant by Docker, what is meant by containers, what is the syllabus that we are going to, how many days we are going to complete these sessions. So these are the things that we have. So any which ways we are going to, I'm going to tell you at the end of the session. I'm going to repeat the same thing in the end of the session. So now, before I go into the concept of Docker and Kubernetes, okay, Kubernetes. First of all, yesterday we discussed about what is meant by a Docker. Docker is just an application. So yesterday we have seen what is Docker. So Docker is just an application to run the containers. So the containers are available. So whatever the applications that are available, you can run the application inside the containers. So before I go into that, did anybody feel that we missed any class, or else anybody newly joined into the session? Just I want to know about that.
Hi, sir. Raviraj this side.
Hi, Rakas.
Just wanted to clarify this. Like, we will be getting the previous day's recording, right? So, like,
Yeah. It's
okay.
just a demo that we did not go very deep into the concept. I have just gone a basic what is Docker, and not about the Docker also. What we used to have, software development lifecycle. Everyone know about that. No? So how the software development lifecycle. Any which ways you are going to get the video. If not, you can see in the YouTube also, that is available in the YouTube.
Okay. So, like,
Or else,
basically, go to the course content, if I'm not wrong.
I will discuss about the course.
Okay, sure. Thank you.
The
Sir.
end of the session, I will show you. Anything else, guys? Any new persons? Okay. So let me talk about what is a container. Okay. Before I go into the container, first of all, let us understand what we used to have. Let us go back to 19, somewhere like 95, some 30 years back. If you go 1995, we don't have these many number of websites. We don't have the Amazon, we don't have Flipkart, we don't have any e-commerce website. The only e-commerce website which we have at that particular point of time is eBay. Okay. And then if you see, we have some, not about the web application, we are having some medical hospital or else hospital applications will be there. At that point only, slowly the banks has been implementing the banks are digitalizing. So which means that not using the ledger books, rather than they are using the computers. They started using the computers from that point of time. So for them, we have to develop the applications. Like that, the IT industry is slowly evolving. So at that particular point of time, excuse me, at that particular point of time, we don't have this virtualization, we don't have this DevOps, we don't have this Docker and Kubernetes. What we used to have in that particular scenario, in that particular situation is that we used to have only a physical server will be there. So there is a physical server. In this physical server, we used to install the operating system. Okay, there will be an operating system, either it might be Linux or else it might be Windows, any operating system we used to install that. So slowly what is happening here, if I want to run an application, so this is my physical server. In this server, I will install an application. Okay, so first of all, we will have an operating system. Inside that, we used to install the application. Okay, the application will be running, and to run the application, what is the requirement for us? Any developers, can you tell me? I am not a developer. I am a system administrator come DevOps engineer. So I have zero knowledge on what I can say, your Java, Python, and all things. But any which ways, I will try to explain you very in detail, but don't worry about that. But anyways, coming back to the point here, So we have an application running inside this operating system. So if an application has to run, what are the basic requirements? If I want to run an application, what are the basic requirements?
Server need to be required.
Just give me a second, I will just come back. Yeah, I'm sorry. I hope I'm able to, everyone are able to hear me. So what we require to run an application. What is our requirement here?
We need web servers.
Why we need a web server? Web server is to, we have a server. It's not about the web server. We want a runtime, right? If it is a Java application, we need to install the Java, or else if it is a Python application, we need to install the Python. Whatever the source code that you have written, you have to run that application. Or else if you want a web server also, in web server, where we have to install that code, whatever the code that we have developed, if you want to convert that code, source code into an application format, you need to have the Tomcat, or else you need to build it. First of all, you need to build it either using Maven or else some another external tools like NPM, Node Package Manager. If at all, if there is a front-end developer, you will understand. So we need to have a dependency that will be converting the source code into a build file. After building that, we need to run it. So to run that, we need to have certain dependencies. We need to have certain dependencies. So when the application is running, so whatever the dependencies and runtime that we are using, that is okay. So here I am having application 1. So if I go for an application 2, if I try to install an application 2, this application requires higher dependencies. This application requires higher dependencies. Whatever the dependencies that are installed to run this application is not suitable for running this application 2. Now at this point of time, can we run these two applications in a single server? Is it possible? Are you able to understand my question here? There is an application and this application 1 is having a dependency, and there is an application 2 which is having some higher level of dependencies are there. This, for example, here I might be using some Java dependencies of version 1. So for this application 2, if I have to run, I need to have the higher level of the same dependency, that is version 2 or version 3 dependency I want. So now, can I run both the application at a single time? Is it possible?
No, sir. No, I guess.
Are you able to understand my question, or else do you have any confusion? At least talk. If you don't talk, I am going to terminate the session. I don't want, I'm very clear about this. I want the students who will respond to my questions and who will be more attentive in the session. If you are not attentive, if you don't want to like cooperate, or else if you don't want to talk, then I don't want such kind of trainees. If you hurt also, no problem. So if you ask the questions, then only I will be able to discuss more and I will be able to deliver more content. If you sit calmly, no, so I can fastly close the session and then I can skip some of the topics also. So I want you to respond first. Do you understand the question or not? First tell me that.
No, sir, no.
Did not understand the question here. Okay. So for example, you are having a car, or else you are having a bike. You purchase the bike, or else what I can say, you purchase a car. So in that car, the car will accept only so a manual transmission is there. There is no automation, or else there is no brake. Right now we got the DBC. I mean, what I can say, automation, transmissions, and everything is. So if I want to incorporate, that updates, I want my car to be have the same updates. Is it possible? It's an old version, no. In the old version, if I want to incorporate the new version, is it possible?
Not possible.
Not possible. No, right? Here also the same thing will happen. So I am having a server. In the server, I am using a application, and this application will accept the old dependencies. So if I am trying to install a new application with the latest dependency, whether these two applications will run or not. That's my question. So the two applications at a single time, they will not run, right? So now to overcome this problem, what we have, this is one of the problems. The compatibility issue will be there. Simply, if I have to tell you, there will be a compatibility issue. To overcome this issue, what I can do here is, I can go with another server. So I will install, I will purchase another server, and I will install this application on the another server. So like that, what is going to happen? So if I need to have multiple servers, then it is a very, very huge burden on the company. Why? Because the servers itself will cost somewhere around 3 lakhs minimum. So it's a huge burden on the company. I don't want that to happen. So then what I can do here? This is one of the problem. The second problem is that, so the application, whatever the server that you are having, this server, the physical server you are seeing here, the physical server will have only somewhere like 8 CPU and some 64 GB of RAM. So this is the server capacity. For example, let us take, this is the server capacity. But whatever the application that you are running, there is no necessity of this much amount of resources. The application will maximum consume up to 16 GB of RAM. For example, take it as an example. If the application is consuming only 16 GB of RAM, then what about the rest of 48 GB? What happens to the rest of the 48 GB? It will be unutilized. So the servers, the applications will not utilize that. So the resource wastage will be there. So the first one is compatibility issues will come, and the second one is resource optimization won't happen. So to overcome all these problems, what we are going to do here is, we are going with a new technology. So the IT industry has introduced a new technology that is called as virtualization. Virtualization. What is meant by this virtualization? There are two types of virtualization: bare metal virtualization and hosted virtualization. So these are the two types of virtualizations that we are having. So they introduced that. So now what is going to happen here means, you have to purchase a server. So there will be a server hardware, whatever the CPU RAM that you are going to get, you can get that server. For example, 8 CPU and 64 GB of RAM server you have purchased. 64 GB or 128 GB of RAM server you have purchased. On the top of this server, we are directly going to implement the virtualization application. Either it might be VMware ESXi or else Windows hypervisor, like that. So for example, I'm going with VMware ESXi or Windows hypervisor. These are all the virtualization softwares. Okay, Windows hypervisor. So directly we are going to run on the hardware, on your server hardware. Now these virtual machines we can create, also on this virtualization, we can create the virtual machines. Okay, virtual machines in the sense, for example, I want to run this application. To run the application, I want somewhere like some 2 CPU and 16 GB of RAM. Okay, so this is the resource capacity which I want. So now on top of that, what I'm going to do, I'm going to install an operating system. Inside the virtual machine, I'm going to install the operating system. And which one, for example, I can install Ubuntu or RHEL or Windows, any operating system I can install. So on top of that, what is going to happen? You can run your application. So I'm going to run the application and its dependency. I'm going to install the application and its dependencies. So this is how the virtualization will be helpful. So now from where this 2 CPU 16 GB of RAM will be given. So the virtual machine will talk to the virtualization software. This virtualization software will communicate the same to the hardware. So now the hardware will give the requested resources towards your virtual machine. For example, you want to purchase some mobile. So you want to purchase, you are not doing any job and you want to purchase a mobile. So now how you are going to purchase a mobile directly? Are you going to, will you go to your father and ask that I want some 16,000 or 20,000 rupees? No. In between, what you are going to do, you will go to your mother and you will ask that I want some 16 or 20,000 rupees to purchase a mobile. So nowadays, everyone are using iPhone. I am not talking about the richest persons. I am talking to a normal person in the criteria. So you will ask your mother that I want to purchase a mobile phone. So can you please ask the father to do some 20,000 rupees? Now your mother will go to your father and ask that. So this is what happened. So you have to give some 20,000 rupees. So then your father will give that. Here also the same thing will happen. So whenever the virtual machine want the resources, it will come. It will talk to the VMware, and the VMware will communicate the same to yours. The virtualization software will communicate the same with the hardware, and hardware will provide the resources towards your virtual machine. So on top of the virtual machine, we are going to install an operating system. On that, we can run an application. So now, if I want to run another application on the same server, we can create another virtual machine over here. This virtual machine may be having some, it is also have some 2 CPU, 16 GB of RAM. And on top of that, I can install any operating system. Here it will be like Ubuntu operating system or RHEL operating system. On top of that, I can run another application with its dependency. So this virtual machine, so the virtual machine 1 and virtual machine 2 won't have any sort of connection, just like two computers. So or else just like two different servers in a single network. Here also there will be two different virtual machines where they are going to run the different application and its dependency. So this is what going to happen here. Okay. On top of that, what I can do here is, if you want, you can create one more virtual machine on which you can run the database. Here I am going to create somewhere like 4 CPU, some 32 GB of RAM. So where my complete server is going to be utilized. My server resources will be utilized. On top of that, I can run or else I can install another operating system. This time I can go with Ubuntu. On top of that, I can run a database. So this is the database which I am creating. For example, if you take it's a Postgres or MySQL type of databases. So like that, what is happening here in a single server, you are going to, in a single hardware, you are going to run the multiple applications. You are going to run the multiple virtual machines, and multiple applications can be running on the single server. So this is the concept of the virtualization. That too, it's a bare metal virtualization. Now, do you understand what is meant by virtualization? Any questions?
No doubts.
So once we have created, then we can start hosted virtualization. So to work with the hosted virtualization, what we are going to do here. So I will just show you in a practical manner so that you will understand the configuration over here. So if you see, this is my computer. Here you can see this is my computer hardware, where I am having a CPU which ranges up to 3 gigahertz, and I am having the memory of 16 GB. So now what I am going to do here is, on top of this hardware, I will be installing an operating system. Here I am having a Windows operating system. Here you can see. This is a Windows operating system. Hosted virtualization is especially meant for the client computers. So this is my Windows operating system. On top of that, I am going to install an virtualization software. I'm going to install an virtualization software like VMware, or else I can install KVM, kernel-based virtual machines like that. I am going to install all the required software. So if I have to show you, get that. So this is my VMware workstation. So now what is going to happen if I want to run a Red Hat Enterprise Linux server? So this is the server which I am running on my computer. So now whenever I started to run this virtual machine, slowly what is going to happen here means the resource consumption will be increased. So the resources should be allocated to the virtual machine now. So if you can see here, look at that. So it is slowly increasing. So 10 GB somewhat from 8 GB to 10 GB it is increased. From there it is going to increase, some more amount of RAM is going to be given to that virtual machine. Look at that. So I am having my Red Hat Enterprise Linux machine over here. So in this Red Hat, I can run an application. So in the Windows, there is another virtual machine which I am having. This is my Windows Server 2016. So here I can run one more application. Excuse me. So see here, slowly the memory consumption is increasing. So now whenever we are running this Windows operating system, inside this Windows operating system, I can run another application. And these two machines are interconnected with each other through the network. So on the basis, they will be interconnected with each other. So this is how your virtualization will be working out. So the same concept here also I'm going to use. This is how. So here, what is this? This is the hosted virtualization. Here I'm having somewhere like 8 CPU and 16 GB of RAM is there for my laptop, and VMware workstation is installed. VMware workstation, or else there is one more software called as VBox, Oracle VBox, and there is one more software called as KVM, kernel-based virtual machines. Like that, there are several virtual machines are available over here. Several virtualization softwares are available over here. So these softwares are going to be installed on top of your operating system. This is my OS. On top of this, what is that? Windows operating system, and it is called as host OS. Host OS. And whatever the operating system that you are installing on your VMware, that is called as guest OS. Guest OS. Like that, what you can do, you can run the multiple virtual machine on your computer itself. So that what is going to happen, your computer resources will be optimizedly used. And now if you see the resources consumption, so it is equivalent to 14 GB. It went up to 14 GB. Slowly it will be reduced. Once the systems are started, then slowly it is going to be reduced. For example, I want to log in into my account. Okay, if I log in into this Windows server also. Okay, so now if you see on the host operating system, I installed a virtualization software. Inside that, I installed 2 virtual machines. Inside that, I have installed an operating system, that is RHEL, and here you can see the Windows server. And if I want, I can run the application inside this RHEL or else inside this Windows operating system. So this is the concept of your virtualization. So this is called as hosted virtualization, or else type 2 hypervisor. It is also called as type 2 hypervisor. Okay, and this is called as bare metal virtualization, or I will call it as type 1 hypervisor. It is also known as bare metal or type 1 hypervisor. It is called as type 2 or hosted hypervisor. Now, do you understand what are the different types of virtualization platforms that we are having? Any questions?
No doubts.
Everything is clear. So why we are going for the virtualization rather than the physical server? From physical server, we have gone to the virtual machines. So previously we used to have only a single server, just like my Windows operating system, just like you can see this software which you are having. Here I can install an application. So if I run a Java version 17 application, Java version 8 application will not run. So this is the main drawback. Okay. But if I create like this, what is going to happen? I can run the multiple. So in this virtual machine, I can run an application which is the older version. In the another virtual machine, I can run an application which is a newer version. So in the same computer, I am creating two logical computers, two or more logical computers, depending on your resource availability. Okay. Right, guys. I hope I made it clear for you. Anything that you want to ask me, you can ask me now. Okay. So now, as per this virtualization, it is very good. So we have created this virtualization software and everything is working fine. And so it is in still 14 GB. Let me shut down these servers. Okay, so this is your virtualization platform. So everything is fine. Now, what take us to the VM? I mean, from this hardware virtualization, this is also known as whatever the virtualization that you have seen right now. It is called as hardware virtualization. We are virtualizing the resources, our hardware resources. Okay. So now there is Docker. What is this Docker? Or I can call it as Podman. Like that, there are different types of containerization platforms are available. So what are these platforms called as? They are called as software virtualization. So this is called as software virtualization. Now, what is the difference between hardware and software virtualization? It is the same, but why we need to go for this? It's very simple. If I want to take a snapshot and send this snapshot to another environment. So now I have created this virtual machine in my computer. If I created this virtual machine in my computer, now I am running the application, that is fine. So if I want to send this application, if I want to send this application with the environment, with whatever the operating system environment that you are having, if I want to send that application to the another environment in the sense, right now I am in the development environment. For example, you have a server and that server is running in the development environment. Inside that server, you are having all the virtual machines. Among those virtual machines, one of the virtual machine is having an application. Now you want to transfer that application from one environment, from the development environment to the production environment, or else to the staging environment. Then how you are going to do that? To do that, we need to pack the entire virtual machine. You need to pack the entire virtual machine and then you have to deploy it on the another server. So to packing that, for example, in this virtual machine, what you will have here is you will have the operating system, you will have the kernel, you will have the application, you will have the unwanted application dependencies and as well as wanted application dependencies. Now, if I have to give a simple analogy, for example, you want to go for a tour, okay, just for a couple of days or for a 1 week, you want to visit a particular place. Now you have your bed in your home, you have your clothes, you have a TV, you have a refrigerator, and everything is available in your room or else in your home. Now, if you are traveling to the another place, are you going to carry each and every object with you? Each and every unwanted object with you? Are you
No,
going to do that?
no.
No, no. What you are going to carry?
Only
You are going to carry whatever is necessary for traveling. For example, a few clothes and then what I can say facial kits, towels, what I can put as toothpaste, toothbrush. So like that, what are the essentials are there? That only you are carrying. Apart from that, you are not carrying all the objects, no. So here also, packing this entire virtualization is like packing the entire objects from your home and you are traveling to another location. So which means that here, what is actually I needed? I actually needed the application to run in another environment. So then why I need to have this virtual machine? Why I need to have the virtual machine operating system? And if I have to explain you in a clear-cut manner, So this application will be getting the resources from this virtual machine only. It is not going to get the resources from the physical hardware, even though logically, if you see, the application will get the resources from this virtual machine and virtual machine will get the resources from the physical hardware. But actually what is going to happen, this application will be able to communicate with the hardware through the operating system. So this operating system will help the application to get the required resources. For example, if I open the Google Chrome, so see here. So in the process management, do we have the Google Chrome running? So here you are having certain processes are running in the background. So for example, if I open the Google Chrome, so my computer is going to allocate certain amount of resources to that Google Chrome. Some CPU, some RAM will be allocated to that. In the same manner, here also, if an application has to run, so it will communicate with the operating system. So whether operating system is going to provide the resources to that particular application, no. Here what is going to happen means, whenever the user wants to open an application, there is a user and this user wants to open an application, he will communicate with the operating system. Okay, he will talk to the operating system and I want to open certain Google Chrome or certain application, certain Java application needs to be opened. So he will talk to the operating system. Once he is talking to the operating system will not directly communicate with your hardware. So in between the operating system and hardware, you will have another concept or else another tool called as kernel. So this kernel is responsible for the process management, for providing the resources, memory management, process management, whatever the application wants. So the operating system will communicate with the kernel and kernel will communicate with your hardware. So it is just like a compiler. So hardware will understand only the language of binary numbers, ones and zeros, and the operating system will not is not able to it is not able to convert that binary format. Only the kernel can do that or else the compiler can do that. So now what is going to happen here, how much amount of resources that are required for this application to run, that will be checked by your kernel. If kernel is not there, your operating system will not work. Why? Because the hardware will be unable to understand the operating system language. So now this hardware will continuously talk to the kernel and kernel will continuously talk to your hardware, so that how many applications we are running inside inside an operating system and how much amount of resources should be provided, everything will be given by the kernel towards your hardware and hardware will provide the required resources. So now here what we are packing here, whenever we are talking about the virtualization platform, so this application will be able to communicate the same with the operating system and operating system will be able to communicate with your hardware through the kernel, which means that I have to pack the operating system, inbuilt kernel, unwanted dependencies, application and application dependencies. If you can see here, it has become a very huge package, heavy weighted package. What is meant by heavy weighted means it is having huge amount of size. Now, if I want to transfer that application, if I want to transfer that particular entire virtual mission from one location to the another location, it will be a very, very problematic situation. Why? Because I have to transfer the entire data, whatever the operating system, whatever the kernel, whatever the application and its dependency, unwanted applications, everything I have to transfer from development environment to the production environment, which means what from one environment to the another environment. So it is a heavy weighted application. To overcome this problem, what we are doing here is we are going for a concept called as software virtualization. We are going for a concept called as software virtualization. What is a software virtualization? That is called as your Docker. Docker or Podman, any containerization platform. So what are the different containerization platforms that you are having? So you are having like Docker. You see here, we are having Podman. So OpenShift is not a containerization platform. It is an orchestration platform. Container D is there. Okay. And then we are having LX is there. Rancher is also an orchestration platform. LXD is there. So like that, you are having several types of containerization platforms. Here they are saying this entire, among those, Docker Swarm is an orchestration platform. Apache Mesos is an orchestration platform. And so they have mixed everything, but the major containerization platforms are Docker, Podman, Containerd, and then you are having I think Runc and RKT. These are the some of the containerization platforms that you are having. Among those, we are going to discuss about the Docker, and inside the Docker, we are going to discuss in detail about the containers. So what is a container and what will be happening inside the container? A container is an environment. Try to understand. I am not saying it's an operating system. It is not an device. It's an environment which is created on the Docker application, in which you can run the application and its dependencies. Only we are going to run the application and its dependencies. Here, environment means we are not going to install the operating system. Operating system will not be installed. We are going to create the libraries and binaries of the operating system. You will have only the libraries and binaries of the operating system. Apart from that, inside the container, you won't be able to see the kernel. If the operating system is installed, then you can see the kernel is there. Kernel will communicate with the hardware. But now in the Docker environment, what is going to happen means there will be hardware. On top of the hardware, you are going to install an operating system, that is the host operating system. On top of that, you are going to install that containerization platform, either it might be Docker or Podman, like that. On top of that, we are going to run the containers, and these containers won't have any sort of operating system. They will use the operating system environment, not the operating system. They are going to use the what I can say, resources, or else they are going to use the libraries and binaries of that particular operating system. Apart from that, they are not going to use any sort of operating system inside them. Okay, so let me show you that. So this is about your, these are all the containers which are running in on your Docker platform. On top of that, we can run the application. Now this is my hardware, and this is my operating system. On top of that, we are going to install the Docker, and then we are going to run the containers. Container 1, and then you will be having container 2, and you will be having container 3. So I am expecting a question from you, but anyways, I'll wait for your question. So this is the container 3, and here you are having the application app, app 1, app 2, and app 3. Application means application and its dependencies will be there. Now, do you understand what is meant by a container? Container is an isolated environment. Isolated means one container will not communicate with the another container by default. Communication in the sense, network communication will be there. So just like if you are running an application in your computer, the same application should not be, I mean, there is no necessity of running the same application in the another computer also. Computers are isolated, but they are interconnected with the network. So they can transfer the data. Apart from that, so whatever the application that is open in your computer will not be opened on the another computer also. That is not going to happen. No? Here also, containers are isolated environments where we can run the application and its dependencies. So that is the definition of a container. Now, before I go into the concept, what did you understand from this entire concept that we have discussed until now?
So in initial process, like uh, to run an application, like we had a lot of dependencies and resource was utilized. And even though if we run like the portability of the application was a bit difficult. So through this we
So,
can achieve.
yeah, through this we can achieve. We can go for the containers. With the help of the containers, we can achieve whatever you are expecting. It's fine. Now, there is a small limitation. Can anybody tell me what is the limitation? I mean, not a limitation. Whatever you have seen in the virtualization that is not there inside this container. What was that? I have explained you a feature.
Resource we can cannot allocate, like there we can allocate resource for
Right? We can allocate the resources for the containers also.
okay.
Anyone? No problem. At least you try to give an explanation. Tell me, guys.
Single OS is there, sir? Like only single OS is there? Like multiple OS we cannot run.
Oh, we can run any Here we are not running an operating system inside the container. We are using the operating system environment. But the point is, whenever we are working with the container, are we installing any operating system inside the container?
No, no, sir.
First question. No. Then how we are going to run the containers and run the application? If an application has to run, what is our basic necessity? We know that if an application has to run, application should get the resources. It has to get the CPU and RAM. No, if the application has to get the CPU and RAM, how it is going to get the CPU and RAM? So the application has to communicate with the kernel, and the kernel will communicate with the hardware and provide the required resources to the application. Okay. So whenever we are working with the containers, in the containers, do we have any operating system installed? Inside the containers, do we have any operating system installed?
No, sir.
No, we don't have any operating system installed. Then do we have the kernel? Or we are having any kernel?
No, operating system is not there, then kernel also not there.
Kernel is also not there. So then how application will get the resources? On the containers, you are having the applications. No? How applications are going to get the resources? It's very simple. So the application inside the container will talk to the Docker, and Docker will communicate that to the host operating system, your Windows operating system or Linux operating system, and the host operating system will communicate with the hardware. So here the containers and the application inside the containers are using the host operating system kernel, whereas in the virtual machines, the applications are using which operating system? The applications are using which operating system kernel? Guest operating system kernel. So this kernel, so the application will talk to the guest operating system, and this guest operating system will talk to the virtual machine, and it will provide the resources to the application. This application will get the resources from the main server. Okay, so that's the main difference between your containers and the virtual machines. The main difference is that the containers are going to get the resources from the by communicating with the host operating system kernel, and this host operating system kernel will talk to the hardware, and hardware will provide the resources. Now there is another question also. So the question is very simple. For example, now let me create a container over here. So docker run, I will explain you about this command, don't worry. Docker run -itd -name Ubuntu container with Ubuntu operating system. Not the operating system, Ubuntu image, I want to create it. So if you can see here, what is the size of an Ubuntu image? The size of the Ubuntu image is only 78.1 MB. Do you have any operating system with that size, 78.1 MB?
No, sir.
No, we will be having that in GBs. Okay. But here you are having only limited resources, that too only the libraries and dependencies will be there. So now if I go inside this container, docker execute -it Ubuntu container and bash. So now I am inside the container. Try to understand one thing. So what is my operating system? My operating system is a Windows operating system. My operating system is a Windows operating system. The container which I have created is an Ubuntu container. Now the application which I am running is also running on the Linux operating system. Now how this application of this Linux environment will be able to communicate with the Windows operating system, and it can allocate the resources for this particular application. How that is going to happen? It will happen with the help of a tool called as WSL. There is a tool called as WSL version. WSL means Windows Subsystem for Linux. You need to install this tool whenever you are installing the Docker on in your Windows operating system. If you are unable to, if you are not able to run it, for example, let me show you. Without that tool installed on your Windows operating system, you cannot create or else you cannot install the Docker desktop on the Windows environment. Definitely, you need to have the WSL. What is meant by WSL? Windows Subsystem for Linux. It is helpful for you to establish the connection or else to understand whatever the Linux container requirements for the Windows operating system kernel. Okay. So here I will show you how to install the Docker desktop on your Windows operating system. Hold on. Let it start. I already gave the syllabus in the yesterday session, guys. If you want the syllabus, you can just go to the DURGASOFT. In DURGASOFT official website, you can see that the syllabus will be there. You can check out that. I think I have the syllabus page. Any which ways, let me check that. Yeah. So this is the syllabus. Any which ways, I am going to tell you. Just hold on a second. Yeah. So in the Windows operating system, I want to install the Docker desktop. How I can install the Docker desktop or else Docker application? Install Docker Windows. Install Docker desktop on Windows, and then Docker desktop Windows x86-64 architecture. So we want this. So what are the pre-requirements? WSL version should be there. WSL version 1.2.1.5 should be there. You have to install that. Apart from that, you will not be able to run it. Okay. Here the application is downloading. So hold on. WSL version. WSL is not there. So any which ways, let me try to install that desktop, Docker desktop. So this is my Docker desktop. And could not load the file assembly culture neutral dependencies. One of its dependencies, the system cannot find the install workflow. Okay, let me try to WSL install course. Okay. Download WSF2 subsystem for Linux. Start turn off Windows features, the subsystem for Linux. Let me check out they have that or not. Here. This is a server node, so that's why it is a different version. So here I want a Windows subsystem for Linux. It's a feature. So it is not that. So if I have a Windows 10 operating system, I can show you that. Just give me a second. WSL install on Windows Server 2016. You can simply give this. So open the PowerShell, Windows or PowerShell. Okay, good. Then what we can do here is enable Windows option feature -- online Microsoft Windows subsystem for Linux. Let me copy this. Uh, Sending that down. Okay, I'll check this out once. So you need to install the WSL on your Windows environment, and then you have to install that Docker. I will check this out once, and I will let you know how you can run it out. Okay, manual installation step. I'm saying that. It needs to have a higher version. So I will check this out, and then I will configure this Windows subsystem for Linux, and then I will let you know about this. Okay. So, but the point is you have to install the WSL. On top of that, you can run the Docker. On top of that, you can run the Linux containers, so that the Linux containers are able to communicate with your Windows environment. Without installing the WSL, it is not possible for you to run that application. Okay. So that's the concept. Now let us discuss a basic things about your syllabus. So here we are going to discuss about the Docker basic, Docker architecture, and then we will be discussing about the Docker networking concepts, Docker images, Docker volumes, and Docker compose and Docker swarm. So the entire Docker will complete it within 7 days. So the total tenure of this entire course will be 20 to 25 days. And the session will start at 8:30 a.m. Okay, and it will close at 10 a.m. So I cannot guarantee that definitely it is going to close at 10 a.m. Sometimes it will be at 8:30 to 9:30. Most probably it will be 9:45. And any time if that particular topic requires high amount of time, then it will go across 10 o'clock. Okay, and the session will be from Monday to Friday. You will have the sessions. Optional 1 week there will be Saturday and Sunday sessions also will be there. 1 week there will be a weekend sessions also they will be there, and you will be provided with the videos and documents. And the prerequisites is that you need to have a basic understanding about the AWS. I don't want you to learn about in detail configurations of AWS, but a basic understanding about the AWS. And what we are going to cover here is we are going to cover the Docker, the complete Docker architecture and everything we are going to cover. And it will take some 7 days of time. And the rest of the 18 days, we are going to work with the entire Kubernetes. So what is meant by Kubernetes and how we are going to work with the Kubernetes, everything we are going to discuss in the next 18 days of session. So this is about your syllabus and the timings and how many duration and what you are going to get with this course. And after completing the course, you can write the CKA exam, Certified Kubernetes Administrator exam. So this course will be helpful for you to write that, to crack that examination. Okay. Now your questions, guys.
Hi, sir. Actually, I had three doubts. So first one is like in the portal it was mentioned like class will start from 9:30. So just now you mentioned like from tomorrow class will be starting from 8:30 a.m.
Not from tomorrow. These are the demo sessions. Demo sessions will be at 9:30 to 10:30. But
Okay.
whatever the actual classes that are going to start, that will be at 8:30 a.m.
Okay, sir. Okay. And second thing, so everything as you mentioned, like we will be executing all the labs and everything in the AWS EC2 only, right, sir?
Yeah, we are going to work with the AWS Institute.
Okay. We will be not executing in our, I mean, local machine.
If you want, you can execute that, no problem. So I don't want to waste my money. I want to work with the, not about the wasting money. So I don't, I want to work with the computer only. So you can, that's your wish. But I am going to show you the complete explanation in the AWS EC2 one.
Yes, sir. Because I also, I mean, most of them we were using office laptops. So,
Yeah, no problem. You can use the AWS EC2 instances.
okay. So, and last doubt, like at the end, we will be like doing any end-to-end projects like deployment or anything, sir.
End-to-end projects, I will not say you won't do that, but I won't say, see, whatever that is required for you to understand the Docker and Kubernetes, the core component, I'm going to discuss about that. At least I will try to explain you about one project.
Sure,
Okay.
sure.
So by, see, one thing I can assure you that by completing the course, you can work with any project. If I say only, if I take an e-commerce website, then we will be using some resources. We might not using some resources of Kubernetes. But if I tell you the entire core concept, then you will understand what we are going to use and what we are not going to use.
Got
Anyways,
it.
we'll see. We'll see about the projects and everything. Don't worry.
Got it, sir. How many days this demo session will continue, sir? Like,
Tomorrow is the last demo.
okay, sure, sir. Thank you, sir.
Thank you. Questions, guys? Tomorrow we will install the Docker and we will try to understand what is meant by Docker network concept. And then from day after tomorrow onwards, we will combine, I mean, your sessions will be started at 8:30 a.m. and we are going to, I mean, what I can say, we will be working with the closely with the Docker and Kubernetes. Okay, so please enroll yourself and join the sessions. If you have anything else, you can ask me. Yeah, go on, your questions. And one more thing, please provide your valid email address and valid phone number. At least provide your valid email address. We want to know whether are you interested or not. We are not going to ask you multiple questions. If you are interested, just say interested. If you are not interested, not interested. Or else if there is any time, you should just give us a reply so that we won't be expecting or else we will be expecting these candidates will be joining or these candidates will are not joining. So we'll have a clear picture. So if you it's just 10 seconds of conversation. Yes, I'm interested. Yes, I'm not interested. That's it. Okay. Yeah. Anything else, guys?
So regarding the joining the course, team will be connecting with us, right, sir? Like they will call us.
DURGASOFT will be communicated. DURGASOFT will come.
Sure.
Okay then. I hope everyone is clear with the topics. If you have anything else, you can ask me. Otherwise, have a nice day and we'll meet in the next session. I guess.
Thank you, sir.
Thank you. Thank you.